Lenz's law states that a current produced by an induced EMF moves in a direction so that its magnetic field opposes the original change in flux. So what does this mean? Well, let's talk through an example. I'm going to have a conductive tube, say made out of copper or aluminium. Now inside of that tube, I'm going to be dropping a magnet. This magnet I'm going to be dropping so that its magnetic field lines come out of the base and into the top. That is to say that its south is up the top and its north is down the bottom. As we have a magnet moving through a conductor, we are going to have an induced EMF. This EMF is going to be producing a magnetic field. But which way does the EMF travel inside of a conductor? Well, first of all, it's going to be traveling around the conductor, but in which direction? Lenz's law says that the induced EMF is going to produce a magnetic field opposing the change. This means that we're going to have our induced magnetic field oppose that of the magnet's magnetic field. This means that our current will need to travel around in an anti-clockwise direction to produce this opposing magnetic field. So, as a question, what would happen if Lenz's law did not hold? As Lenz's law stops us from getting free energy, the magnet, as it's falling through, if the induced magnetic field was in the same direction as it, the magnet would actually accelerate within the tube dramatically, and it will get faster and faster and faster, and it would, just by putting it in lightly, would fly out the other side with a huge velocity. This also explains the negative in the EMF generation, Faraday's law.